All right, so you're set. So welcome to today's class, and like I previously said, we'll try to do as much as possible because I most likely would not be available on Friday. So please just bear with me. So I'll try to do as much as I can to cover what we were meant to do, you guys were meant to do last week, and what you're meant to do this week. Because what we were talking about yesterday throughout was still even last week. So I'll try to rush through what we're meant to do, you're meant to do last week, and also go into the one for this week. So yeah. So yesterday, okay, before I go ahead, does anyone have any question from yesterday? So did you check out one or two things, or like did you see anything, or it's just basically any question you would like to ask before we go ahead? Anybody, you can just speak or just drop a message on the chat. I would go over that. Like,
Sorry.
yeah, go ahead.
Yeah, what if it's not related to what you've taught us so far?
Okay, just go ahead. Go ahead.
Okay, I think it's still related. Okay, so the thing is, I have issues with understanding reference types
Okay.
properly, where the old storage and referencing and all of that. Can you please explain it properly?
All right. So a lot of these things are kind of will I use the word deep, but most times when if you want to really understand it, it will take a while because a lot of dots to start connecting. But basically, when you're talking about value type and when you're talking about um reference types, in value types, for instance, now if I have a variable that's a value type, say uint or int, so basically integers, and I declare it at the beginning of my contract. So I say uint a equals to 5, and somewhere in the contract I want to use a. So basically, when I call a, it is basically copying that a from there and bringing it into where I want to use it, right? So it is basically copying it the way it is, copying everything and bringing it to this new location that I want to use it, right? And it's now kind of, it's copying the value, you understand? So the one that I declared and the one I'm using now are two different values. So I'm copying the values, right? So if I do uint a equals to 5, and I now do uint b equals to a, then if I change b, I do not really change a, right? Because they are two different values, right? But imagine a reference type. Now, if I set a reference type, say an array, and I set it at the beginning of the contract, and I say uint array is equal to uint array 5 is equals to an array, and I reference it somewhere in the code, and I now okay, I now say, okay, let's say it was equals to x, so I will say uint array equals to x. Then I now do y is equals to x. That means I'm taking the value of x and putting it into y. Now what happens is, instead of it to copy, just like it works the way it works in value types, instead of it to copy, it just references it. It doesn't copy it. It just says, okay, I know the memory location of this thing. Let me just point to that same value rather than copying it from where it was before. Do you understand? So this is how it works. So if I now do y is equals to x, because x is already defined, I already defined x up, and then I now say that y is now equals to something else, another value array, sorry, another array, or I try to push value. I try to do dot push, like a lot of arrays have in other programming languages. I think, yeah, Solid also has push. So when I try to push a value or I try to pop a value, that modification I do would affect both x, because they are all tied to one memory location. And when I'm trying to edit or when I'm trying to manipulate, I'm manipulating it back to the reference because they are all pointing to one reference. Do you understand? So I think this is on a high level, but as you kind of explore, you would see even it's sometimes it's good to bring in your like in the idea of pass by value and pass by reference is not even just tied to solidity. So you probably see it used in like C or C++ because of they're already popular, you probably make sense of them. But this is the basic idea, and this is how it works basically. So does that make sense?
Oh yes, it makes sense. But sorry, so how does it relate with um storage taking space and costing more and all of that?
Mm, specifically, I won't say, or rather, I haven't seen. Um, I won't really comment on taking space because I won't really comment on taking space because I've not really seen much about how whether pass by value is more expensive than passing by reference. I don't really know about that. I don't think I've not seen it anywhere basically. I've not seen it anywhere where they say pass by value is more expensive than passing by reference or stuff like that. But yeah, I don't know. I've not seen that before. Yeah.
All right, thanks.
Can you hear me?
Yeah, I can hear you, but it's not clear. But go ahead. Let me see. Go ahead.
Okay. Please, I wanted you to like go over constant and immutable again because I'm finding it really hard to understand. I got lost at a particular part yesterday.
All right. All right. So let me quickly do that. Then we go ahead. Yeah. So like I said basically constant and immutable, they are trying to achieve the same thing. But using constant, it is assumed that you already know your value even before deploying the contract. But using immutable, you are given the grace to set that value when you're deploying the contract and not more. Like you can't like in constant you have it like the way I'm showing it here. Here I use equals to my name, God's power. But now because of immutable, they are giving me the grace to now set it. Set like now I didn't set any value here, but they are giving me the grace to set it inside of the constructor. You get they're giving me the grace set inside the constructor. So that's like the main difference. Constant, you need to have the value even before deployment, but in immutable, you need to have the value at most when you're deployed. Because if I don't set this thing now, if I comment this out, I have an error because I need to set it before deploying. So they are giving you the grace to set it here. Meanwhile, this one you are meant to set it outside. Like you need to have the value beforehand before deployment. So does that make sense?
I have a question, please.
Yes, it does. Thank you.
All right. Okay, go ahead.
Yeah, in what cases then do you use immutable?
Um, so off the top of my head, I'm trying to see. But in a case whereby you want to set a constant value and you know that that value will never change, but you don't know it beforehand. Say you want to set the owner of a contract, right? Manually. And you know that you don't ever want the owner of the contract to change. You understand? You don't want it to ever change. So instead of you to now hard code your contract by doing like coming to paste your contract, your address rather here, you would not say that this just like what we did here. When I deploy the contract, let the person that deployed it be set to this. So there's a value I want to set that should be available throughout the lifetime of the contract, but I don't know it beforehand. Or rather, I don't want to set it by myself because there might be cases where, okay, I might write the contract and come and paste my address here. Meanwhile, the person deploying it is someone else. But the rule is that anybody that deploys this contract should be the owner. So that is like something that comes to mind when I think of a good use case for immutable. But there are different other cases where you need stuffs like this.
Okay, thank you.
Yeah, you're welcome. So yeah, yeah. So that's it for questions. If you have questions, we'll deal with it later. So yeah, and also so I want to continue for where I stopped yesterday. During the class, if you don't understand or you want to clarify something, you can drop it on the chat or you can just unmute yourself and speak. Yeah. So I stopped that. I wanted to explain string yesterday and I just decided to skip it. So yeah, I'm talking about data types. And also today I'll be fast, or rather I'll just skip some things that I feel like they are not that you can go and read up. And as I said yesterday, please explore by yourself. Like these things will not really do much. No matter how I try to teach here, and you will not really gain much if you don't go and explore by yourself. Because like I don't know how good you are able to like cram things, or how good you are, how well you're able to retain things, but no matter how good you are, if you don't practice these things, it just take a while before they leave. So yeah, please go ahead and in your spare time try out these things. So the string type is a reference type, right? And because the way a string is stored, strings are stored as dynamic byte arrays. Now, what am I trying to say? They are stored as dynamic byte arrays. They are not stored as just this, in the data in the contract. They are stored as dynamic arrays. You understand? So let me just write that. So later when I talk about arrays, it will make more sense. So dynamic dynamically sized. Okay, okay, not byte arrays, but yeah, they are arrays, but don't worry, I'll explain that. I don't know. Have you heard of UTF-8 before? I think it always comes up.
Yes, we use it in Meta for the HTML image.
Yeah.
So
I
it's
think it's popular.
that we use on Meta. Yeah.
Yeah, it's a string encoding. Yeah, it's a popular string encoding. But basically, what you're trying to say here is a string under the hood is stored as an array of bytes. An array of bytes. So yeah, it's stored as an array of bytes, and just using it like this, you would not really see a lot of these things come to light. But when you now try to, because now I can decide to do something like this, I can decide to store this using this. I can decide to store this using bytes. Okay. Okay, let me change the bytes 32. I think that will make more sense. It's 8 is not basically converted to 8. Okay. I guess let me just talk about array first because it is very funny. When I use it, it actually makes sense. So if you want to define arrays in Solidity, how you do it is, so there are two types of array. You can have fixed size arrays and dynamic arrays. So that's where this dynamically fixed size array comes. Dynamically sized bytes comes in. So you can have fixed and dynamic. So you can have this. So you want to have an array of numbers, right? So you can just do this and say array of numbers. You get, so this is an array of numbers, right? And this is a dynamic array. But if you wanted to have an array, a fixed array, you get, so you can just do something like this. So now you want to have an array of 5 numbers. So basically, this is an array. You get, you want this, if you want to define an array of numbers, this is how you would do it. Now, there's something interesting about this. If you try to, because this gave us public, right? And we know that once something has a public visibility modifier, it gives us a getter function. But watch something now. So if I deploy this, if I deploy this now let me deploy it and show you something. So when I deploy this and I try to get this array, see what they're telling me? They are telling me to impute an index. They're telling me to impute an index because of gas, because of the fact that you might have an array of 1 million elements. Say even for like both of this now, you might have an array of, I can change this thing now to like 100 or I don't know, a lot. You get. So they are not allowing me to get all the values of these arrays. They want me to pass in an index. So just with public, you can't get all the values of an array. But I can now decide to do this and say get all values, and then do this, try to return the array. So now if I redeploy this, now here they're telling me to pass in an index. I know now we've not done anything to the array now, so it should give us the normal on the invalid index or something like that. Basically trying to get a value that does not exist. So it threw an error. Understand? But if we call this one, it will give us an empty array because this doesn't contain any value yet. But now you see the distinction. Just using public, you are not able to get all the values. But using this, you are able to get all the values. So we cannot have a case whereby you want to have a nested array. So you can now do this, say so you can now do this. So you want to have an array of 5 dynamic arrays. So this is how you do it. You do this and then you put this. So basically, this first array, they are dynamic arrays, but now you want to have 5 dynamic arrays. So you can now say this. Yeah. So now this is a nested array. So basically, this is an array of 5 dynamic arrays. You get. So an array has some members, right? An array has you can find the length of an array. You can find the length of an array. So let's just quickly no, I tried to do this yesterday, this one, and it didn't work because in as much as a string is an array, it doesn't allow dot length, unlike other programming languages. Right? Unlike other programming languages that allow that. So yeah, it allows you to use .line. So let me just, or rather, let me just give you the members. So it has so when I mean members, I mean both methods and attributes. So it has, you have .length, you can have push, you have push with an argument and without an argument. So you can have push with an argument and with an argument. So just to take note, all these things are the documentation. But I just want to bring out the important things, because the funny thing about giving out information is that you might want to give out all the gems and stuff like that, and at the end, people just pick some. That's the reality. There's only a lot we can pick at the same time. So just know that you can always fall back on documentation anytime, any day. Yeah. So there's also pop.
Hello, which of the documentation?
Solidity documentation.
Okay, you mean we can find all these on the solidity documentation?
Yeah, you can. Let me send
Please,
it.
can you do the link?
Yeah, I'll do
Because
that.
I'm confused.
Yeah, exactly. Yeah, these things are okay. I think what I'll do is basically just go over the high level stuff, because a lot of these things, you feel like they are important, but when you give everything at the same time, they now start to become very confusing. So I'll send this. Let me send it on the chat. Because so yeah, thinking about this now, just know that I wouldn't even want to try start going into each of them, because I feel like they become more complex and it will be time consuming. But just like in other languages, the way length works, the way push works, the way pop works. If you're looking for like specifics, you kind of check out documentation, or you ask me on my DM, because I know that it will be kind of confusing if I go over each of what this does, and it's also take time. So that is that on arrays. You can do the basic things you can do with an array normally. Yeah, and Solidity doesn't give you all of it. You understand? If you go to other programming languages, you have like 1,000 methods to use, but these are most what Solidity gives you. So let me just quickly brush through this. So just to take note, arrays is a reference type. So you don't mix up this. Array is a reference type. Have you guys talked about addresses as a type?
No, I don't think so.
Okay.
No.
Okay. So okay, let me quickly talk about that, because that's under value type and it's really easy. Yeah, it's really easy. Address is like, so let me quickly talk about that. I'll talk about I'll touch strings again, and we'll just go ahead, because I think this is taking a lot of time. So addresses. So I think the only thing unique, I think addresses is one of the unique things about Solidity. You must have heard mapping, you must have heard integers, you must have heard strings in other programming languages. In fact, if you've not heard of mapping, you will have heard of dictionaries or objects in JavaScript, or dictionaries in Python. So addresses are 20 bytes numbers. So if you don't understand that, just addresses is what you know as addresses. So basically your Ethereum address. So that number now, it's a 20 byte address. It's a 20 byte number. So let me just quickly look one address. I know you guys understand what I mean, but just for the sake of. So yeah, this is what an address looks like. This is an address. Okay, no, let me use another one. This is my. Let me use another one. So yeah, this is an address. This is what an address looks like. And there are two types of addresses in Solidity, or there are two types of address types. So you have normal address and address payable. So what this means is that one of them can receive Ether and the other cannot receive. Normal address cannot receive Ether. This address can receive Ether inside the contract. You get, it's not like somebody wants to send you token now, they'll start to ask who is, no, I mean inside the contract. Inside the contract. So basically now, this is how addresses are defined. You can have owner, and I'll just define this without double quotes. Note, you don't put it inside double quote, it's not a string. Okay, there's already, okay, owner 3, I'm just owner 3. So just like this. Now, this, if I want to send Ether to this address, it won't work because it is not a payable address. So let me just write function quickly. So function send Ether. I do owner 3 dot transfer, and I do MSG dot value, and I make this payable. So let's see what the errors will be getting. Now, what I'm trying to do here is that I'm trying to transfer, because I said yesterday that MSG is an object and it has like attributes tied to it. So it has dot address, it has, is it dot address? Sorry, dot sender, it has dot value, it has dot data, and yeah, it has these three things among others. But this dot value basically means how much Ether was sent to this contract, and it is given in way denomination. So, okay, go ahead.
Sorry, please, what does this MSG do?
MSG, MSG is like a global object that comes with Solidity. So anytime you call a function, some attributes are tied to it. So like I said, the sender, which is dot sender, the value, which is the amount of Ether that was sent in that transaction, and dot data, which is the information about the function you want to call. So those three are like the main ones. I think there are others. So yeah, that's what it does. It's like it's an inbuilt object that comes with every transaction. Does that make sense?
Yeah.
All right. So yeah, so what this function does, or my goal is that I want to, anytime anyone calls this contract, it will just send the amount of money that the person sent to the owner, which is this owner here. And now see what I did here. I made this function payable because only a function that has the payable modifier would be able to receive Ether. So if I don't put this here, it won't be able to receive Ether, but we'll still have an error because just like I said before. Now let's see the error. Okay. This is another error. Now let's see the error. They said send and transfer are only available for object type address payable, not address. So this address is just a normal address. It is not an address payable. So if I want to make this an address payable, I would do this. Okay, now let's see the error it's given. Address type address is not implicitly convertible to address payable. So what they want us to do is that they want us to convert this explicitly. So you cannot just, they want to convert explicitly. So let's do this. So now I'm converting this address to a payable address. So you see what I did here was not enough. Even if I said I told them that yes, I want it to be an address payable, they said I will still convert it because it's like I want them to convert it implicitly for me, but they say they can't do that for me, right? So I need to convert it with this function here, payable. Now, because of this thing I added here, now this function can receive it. Okay, Chemaka, go ahead. Okay, so now because of this address payable I added here, I'll be able to receive it. You get, so these are
Hello,
like,
sorry, can you hear me?
yeah, I can hear you now.
Okay, sorry, I did not unmute and I was speaking.
Okay.
Okay, I'm sorry. So, if when you were creating that address, let's say if you already like use that table keyword, like before even writing the function and everything, would you still need to explicitly convert it?
No, no. So let's try something now. Let's do this. Let's do this now. Okay, Elizabeth, go ahead.
Okay, my question is it any address that can become payable?
Yes, yes, yes. Any address can become payable. Okay, so the question you just asked, I think now, yes, we need to convert this address to a payable address. I think that's what they're saying it here. So type address is not implicitly convertible to expected type. Okay, okay. Let me do something here. So let's say now in this case, we would need to we will need to convert it explicitly. But imagine this was the case that I was doing this. I actually defined it like this and pass the address here. Let's see what this gives us. Now this works, right? Go ahead, Elizabeth.
Oh, sorry, I forgot to lower my hand.
Okay. Okay, Chiamaka, do you understand now? Because of I made the argument type payable, it's able to add this without giving me that error. But if I'm bringing in a value and I want to set it, then I'll have to convert it explicitly. But now, because of this is I already said that this should be payable, then it doesn't tell me to convert anymore. Does that make sense?
Okay, thank you.
Yeah. So that's what's happening here. If you bring in a value and you don't set it as payable beforehand, you would have to convert it using the payable method, payable function. But if you already set it as payable, just like we did here, then you wouldn't have to set it, convert it explicitly. Okay, go ahead.
So is it possible that you drop video resources? Because I personally understand better when I watch videos than reading. So I don't know if you have video resources on how we can learn how to use each of these functions and what what is being
Mm,
required and when we are meant to use it.
okay, okay. Um, okay, I'll share some resources later, but you won't really find a video where they just tell you how, like, talk about these specifics. Like they just tell you how to build, like they are building something and just tell you this is why they did this. But I don't think you find a video where they just talk about what is what, like individually, like address table and stuff like that. Documentation is best for specific things like that. Yeah, go ahead.
Okay, so is it, I don't know, is it possible that in this class you like so the last assignment we did was to do a CRUD operation with Solidity. Like, is it possible that you do that here and like show us maybe the best way to do it, or just show us how you are doing it and maybe explain while doing that.
Okay, okay, okay. Yeah, that makes sense. But something is that we are actually out of time. Like we are supposed to do what the things for this week and even next week now today. So
Let me see answer. Let me see answer. He did it yesterday. So I don't know if you were in yesterday's class. That was the question I asked, and he was able to call those functional data regarding the assignment.
oh, okay,
So
yeah, I
maybe
think
if it's the one you did yesterday, that's what she's referring. That's the only assignment he's been given so far
I was in
on
class
Saturday.
yesterday, but like I just mean like the whole function and everything.
Okay, from the beginning. Oh, okay. All right.
Yes, all the functions, view, everything, all of that.
Well, you can
okay,
also
okay,
check the resources linked to that assignment. I think that was what I used. There is a guy who it was this video I followed in order to do that assignment. So and he really explained it well as well.
All right, thanks.
yeah. So let me just quickly move to string. I think I've talked about strings too much. I was just going back. Sha, strings from the outside, you nothing like you won't really see much in terms of how it's stored, like in terms of it's being stored as a dynamic array. But the way it works is under the hood is being stored as an array. But when you just use it like you save it as a string and you call it, it gives you a string. So, but the distinction between a string and an integer is that when you're calling it, rather when you're passing it as a variable, sorry, as an argument in a function, you would need to use memory or call data, you get. And also, you just treat it like a reference type. So, yeah, I think let's just call it a wrap on. Okay, let me also talk about enums. I think enums are important. It's a value type too. Let me talk about enums. And I already talked about structs. Struct is a reference type, but I already used struct yesterday. So I just want you to just go and check it out. I already used it to explain things yesterday. I think yes, this is struct and it's a reference type, but I already used to explain it yesterday. So just also take your time and like look at it. So enums is a way to set values that you know you would want to use in the code. At the same time, you don't want to be repeating them. So imagine that you have a multi-choice question and you want to, you know that this thing, the options are finite. So you have only three options. But you like now, in some cases, you will now say, okay, I have three options, which is okay, let's just say let's say two options, yes, no, yes, and no. Now, you don't want to start writing yes everywhere you need to write yes. I don't want to start writing no everywhere you need to write no. So we set these things beforehand so that we can just call them, you get. And anytime we do dot yes, we have yes. Anytime we do dot no, we have no. So let me just write that out. Mm, okay, go ahead, go ahead.
Do we only use enum when we are having two comparisons that are fixed? Example, like when we talk of gender, we have male, female, others. Is it or
Yeah.
when you talk of yes and no? It's only when we have comparisons that's when we can use enum.
Mm, in most cases, you use enums when you have a finite set of values that you want to be able to use multiple times. So yeah, yes or no is one, gender is another one. You might have other ones, but yes or no is just like one example. Gender is another one. You can
Because
have
another example is like level, novice, intermediate, advanced. So I was thinking that
exactly.
is it only when you have those kind of options that you can use? That's the only data that work with enum.
Yes. So
Okay.
I wouldn't say in Solidity, but in TypeScript, there's a way to set values for these enums, but I don't think it implies it happens. So let me just show you something. So let me do choices. Let me just show you something quickly. Choices, and let's say yes, and let's say no, right? So now this is what this how it works here. Now, in TypeScript, for instance, you can do something like and set that you want this value to be run or something like that, or affirm. Let's just get, and let's say this is disagreeing, but this doesn't work. Yeah, right? This doesn't work. This is Solidity. So assuming you were able to do something like this, then let's say you be able to use it for more stuff like that. And I'm not saying that these things are the only thing. You can be decide to be creative and use it for anything you want, but this is how I'm using it right now. And this is what it's mostly used for things that are finite, but you don't want to keep repeating them. I know that under the hood, this thing are actually set as numbers. So this takes a 0 and this takes a 1. So let's just say we want to return my choice, or rather, I want to set my choice. Let's say choice is the type, because remember I said it's a value type. Choice is the type. Then let me now say my choice. Now do equals to choices dot yes. Now this is my choice, right? And if I want to return it, you see what to return. So let's say get my choice. Get my choice. I want to return my choice. The return value would be the choice type, which is what we set up. Then let's make this public. And yeah, add this, we make this return instead of returns. Okay, this is a view because it's not modifying anything. So I think we are good. So let's deploy this and see. So let's deploy this and see what this gives us as the end value. Okay, now they want, okay, let me remove this thing. I don't want to pass in. Okay, let me just pass in our address. Because now, see what happened here. Now, when we want to deploy it, before there was nothing here. You understand? But now the constructor requires a value. So before I deploy, I need to add that value, like I said. So now, before I deploy, I need to add that value. So when I deploy, I've deployed now. So just take note of that. If you pass in an argument to your constructor, you have to pass that value when you are deploying your code, your Solidity code. So where is it? Get my choice. Get my choice. You see 0. You get, so this is 0. So there's this assumption that it's finite. So you have 0, 1, 2, 3, up to. You can have 5 values, you might have 10 values, but I know that it's mostly used when you have finite options and you want to pick. I don't want to keep hard coding them and typing them out. You can just go back to get these things. And like I said, in TypeScript, you can set your own values for them. But here, you just leave it as 0, 1, 2. As if I add another one here, maybe I'll take 3. Sorry, to take 2. 0, 1, 2. So this is how enums work. You can read more upon can read up on it, and you'd see how it works better. So does this make sense? Does enum make sense, or do you want any clarification?
I understand. But my issue now is that why is it that most of these data, because when I did the data, I was a little confused after deploying because most of them were in index numbers 0, 1. How would somebody want to retrieve a data using that index if they do not know how to read the contract?
Do you mean
Because
the
now,
value of year?
we are right. Yes,
Just like value of
we know that 0 is, 1 is no, 2 is
yeah.
maybe. But let's say someone is trying to call that data to know exactly what enum function, and it brings out that number. Why is it not bringing the exact value attached to that index number?
Okay. So yeah, this is a very good question. But most times the enums are not really returned. Most times they are mostly used for conditionals inside the contract. So they are like, if you say yes, do this. If you say no, do this. If you say maybe, do this. Most times nobody's returning 0, 1, 2. You get. I don't. I personally, I wouldn't write my
Okay,
code to be returning those
okay,
values individually. I would just want to write my logic around them. You get. I would not want to write a code that is returning 0, 1, 2. Who knows what 0, 1, 2 means? Or what if I want to keep adding values? If I make like a contract that's upgradable and I want to keep adding new up choices, you get. So in most cases, I just did it here because of so you see what it actually the way it saves it. That it doesn't really. For instance, like if I wanted to like do a conditional now. I wouldn't use 0, I wouldn't use 1, I wouldn't use 2. I'll do if my choice is equal to choices dot yes, then do this blah 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 blah. Or return good. Return good. So now this will now return a string. If you look at what I did here, I am not name return. Okay, this is not an error. It's just a warning. So basically, see how I use it here. I'm using it to make decisions inside the contract. In most cases, you will not be returning those values. I'm just trying to show you how they are stored. You get. So let's quickly talk about functions, function types. A function type is also a value type. Joy of these things or the fun of these things is when you start experimenting it yourself and you start having these aha moments where you're getting things that you probably heard before and it did not make any sense. So please go ahead, take your time and look at these things, explore, build contracts. They will really help you understand these things better. So, okay, let me do function types. You know, I've been using functions since, but I just want to talk about the things I've been talking about since. So, function types. Oh, yeah, function types. So, you know, when we start classifying things, sometimes it adds a lot of complexity to things. So, for instance, if I tell you types of function, I'll start listing functions for you. In reality, nobody wants to really ask you what are the types of functions. But if you see them, will you know what they are doing? Now, I can decide to differentiate. I might decide to say, okay, there are payable functions and non-payable functions. What do they mean? So, payable functions and non-payable functions. So all these things are just like big English. What does it mean? Payable functions, functions that can collect ether. Non-payable functions, functions that cannot collect ether. Simple. If while calling the contract, I need to pay or I need to release ether funds, then it's a payable function. Or at least I should pass in at least 0 ether. It's not much you must send though, but at least at least let it be 0. You get that means the function can accept if you send. You get that function can accept ether if you pass in ether while sending it. It does not really mean that it's a must that you must send ether, but it can accept if you send. But if you use it for a non-payable function, you cannot even accept. In fact, the message of value will not be available for you. So let's just try this thing out. So let's say function. Let's just say function accept ether. I want to do return MSG of value. Now, I'm not really doing anything with what money you send. I'm just returning it. But you would see what they'll say. So uint, because it's the uint value, MSG of value is a number now. So let's see what they are saying. Let me add public. Let's see what they're saying. Let's see what they're saying. They are saying MSG of value and call value can only be used in a payable function. Then blah blah blah. So what am I trying to say? The only time MSG of value is available for you is when your function is payable. So if your function is not payable, there's an assumption that why are you using MSG of value when you're not even supposed to receive it in the first place? So if we just come here and now add payable now and like add payable here, the error is gone. Now you can accept, even if we're not using the money. Like what will happen here now if you send money is that it will just you just save the you just save the ether to the contract, and that's all. Like a contract can hold ether now. Like you can go and check the balance of the contract. So what will happen here is that as you send it, the contract will now be the owner. And unfortunately, if you don't have a way to send out ether, it will just be there forever and nobody will be able to send it out. But that's the story for another day. So this is basically the difference. If you add payable, you can collect. If you don't add payable, you cannot collect. So now let's now talk about this thing based on these things we use here. So public view. So now let's talk about pure and view functions. I used it a lot yesterday, but I just want to talk about it again. Now, in a pure function, or rather in a view function, that function should not change the state of any value in the state. I think that's a bit complex. Let me just write it down. So imagine that I wanted to do this. So function change owner. Change owner. Change owner. So change owner. And here I want to take in an address of payable. And this is the argument, right? So one taking this and want to now say owner. The owner I've said before, where is it? This one now. Want to change it. Want to change it. Owner 3 is equals to address. Now what happens is that, okay, let me just set this to public. And now set this to view. I want to show you something. Now we have an error. You know, when I didn't put view here, when view was not here, this is a normal function, no issue, it's working. But when I put view, now let's see what they're telling us. Function declared as view, but this expression modifies the state. Do you understand? Now, what we are doing here is that we are modifying the state. Any value that is defined outside the function, all these values now are state values, are state variables. All these values now, these values are defined here, all of them. See all of them here. All of them are state values, state variables. If you want to change anything in them, because now what you are changing is that you are changing the state of the contract, and at the same time you are changing the state of the blockchain, because the contract is on the blockchain. If you change something inside of the contract, you are changing something out inside of the blockchain. So now if you want to modify state, this view should not be here. You understand? So that's that. In a view, that if you set the function as view, that's why if you create a function that doesn't modify anything, they will now start suggesting to you with the warning, the yellow warning, they will tell you that okay, put view now, as you're not changing anything, just put view. It's not like it's a warning, but at least put view. Let's know that it's not modifying anything. But now, if you put view here, if you put view here, if you put view here, then they give us an error. Now let's not change anything so that the error can go away. So let's just do return owner. Return owner, and here export returns address. So okay, there's an error somewhere. What did it say? Expected days but got this where? What did it say? Returns address. Okay, we're not really using this for anything right now, so let's remove it first. Okay, okay. So this is meant to be inside here. You want to say something? Please go ahead. So yeah, this should be inside here. Now the error is gone. It's now just it just returns a value. It just returns a value, nothing else. So the error is gone. But now, if I change this now to pure, let's see what we get. We have an error again. What are they saying? Function declared as pure, but this expression reads from the environment. You know, view is like it's telling that you should not modify. So it's a bit it's not that strict. But pure is telling you that don't even call anything on the state. View is telling you, okay, don't modify. You can call or you can use it, like you can just return it. But pure is telling you don't modify, don't even call it at all. So see what it's telling you. It's telling you that declared as pure, but this expression reads from the state, from the environment. So it's telling you that since this is set as pure, you're not even meant to read at all. So if you want this error to go away now, we'll just create values that are only inside of the function. So if you want this to go now, let me just do something now. Let's set sorry about that. Can you hear me?
Yes, I can.
All right, cool. So now if we do this, let's see what we get. Okay, I need to change this to unit because now we are returning an integer. Voila, it's now working because now we are not calling anything in the state. The sum that we did, it is inside the function. The returning we are returning is inside the function. Nobody's calling from the state. Now it's telling you that okay, it's fine. Now this is the difference between pure and view. View, don't modify. Pure, don't modify, and at the same time, don't call, don't touch anything on the state. Just look for values and using it inside the function. That is what they're telling you to do. So so let's now talk about these things that we've been using: public, external. Okay, these actually take a lot of time. So I'll just talk about them. Okay. I might actually go through them. Sure, I'll just be going. Internal and private. Yeah. Okay, let me just create. Let me just do this so that you have, so it's not be like it's only pure we talked about, so that you can also see this and make sense of it. Let's change this to pure to view and return owner. I want to make it easy to read so that you can see how it started and where it's going. So now this is how owner works. Okay, let's return owner. Return owner. This returns the owner, and this just does addition for us. So now let's quickly talk about, I made a comment yesterday, which is not wrong, at the same time it's not right. I said when you set a function as external, you can't call it inside a function. That is not exactly true, because you can call it inside a function, but when you want to call it, instead of you to just call it the way we call things here, you will now use this dot that thing. Let me explain that. So let's first explain public, then we'll explain external. So I've been using public since, but I don't even need to explain public. I've been using it since. If you set something as public, you can call it inside a function. And if you set a function as public, you can call it inside the function, and you can call it outside the function. You can call it anywhere, basically. So far, whether inside the contract that is inheriting it, you can call it everywhere. Now, when you set a function as external, let's see it in practice. So let's say function do something. Let's set it as external. Something. Actually, you're not doing anything, but yeah, let's just say you do something. Return 2. And let's do returns games. This is fine, right? So okay, this is even pure, not even V. So this is pure. See what I did? 2 is from inside function. It's coming from nowhere, so it's not even talking to the state. So pure is fine. But now, if I want to call this, let's say another one, call do something. Very bad with all these names, but let me keep playing. So if I now say I want to, let me make this one external again. It's not like I'll use it again, but I just want to make it fun. So now, if I want to call this function, let me say returns viewing. So, and let's say viewings something. It's doing something. So if I want to set, it's fair if I set it as something. So if I do this now, and do this, it's giving me an error. Let's see what it's saying. It's saying undeclared identifier. That means it is not saying this do something, unless I call it as if I'm calling it from the outside. So if I now come here and do this, and I do this now, this or this, it works. It actually works. You get. So what I meant yesterday was you can't call it using the normal thing. Like we've been calling things now. We've been calling things everywhere. We've been calling things like just bringing them inside. You get. So, but you can't call it like that. Or set to use this. Now you can now return something because something has been added to the something has added something to something. So yeah, they say I've set this as view. That's it. So you can't call a function that has external as the visibility modifier unless you use this dot that function. So that's that. Then internal. Okay, we've not started doing inheritance, but let me just write a comment on internal and private. So when I get there, it will make more sense, or when you're looking at it yourself, depending on whether we are able to go there today. So internal and private. For internal, you can, in fact, first of all, using internal and private, if a function is internal, you cannot see it here. You get? If a function is internal, you cannot see it here. If a function is private, you cannot see it here. First thing. If a function is internal, you can't see it here. If a function is private, you can't see it here. That means you can't see it out of the, like, you can't get it when you're not in the blockchain itself. When you're not inside the smart contract, you can't get it. The only time you use private and internal is when you're inside of the contracts. But I'll tell you the difference between two of them. Now, internal, using internal, you can call it inside its own contract and inside a contract inheriting it. You understand? So if I create a contract, if I create a contract and I'm inheriting and I set a function, let's say we set a function and we make it internal inside of this one now that we are seeing. And we create another contract and we inherit from this contract. That function will be available for us. And also it will still be available inside this contract. And it's not using this dot something to you use it normally. You know, like if I make this external, let me just quickly do this. If I make this internal now, I don't need to put this. If I just do this now, it will work. We get, because it's now internal. I can call it from inside. You get. So let me just go back. So if I make it internal, I can call it from inside the contract and from inside the contract that's inheriting it, not outside. Not outside, not here. You understand? Not here. So then in terms of private, the only difference between internal and private is that private is like very strict. You cannot even call it, you can just call it inside its own contract. That's all. You cannot even call it inside the contract that is inheriting it. If you understand the idea of inheritance in other programming language, I think this will make more sense. But when we reach inheritance, hopefully, we'll talk about that. So you can call it only inside its own contract. So that's that. I think that's all for functions. These are different kind of functions. And like I said, nobody will ask you what are type of functions. We just want to know if you're able to use these things. Giving you type is just to be able to, just to explain. It's not really that you need to know that there are different types, but just when you see pure, what does it mean? When you see view, what does it mean? When you see public, what does it mean? When you see external, what does it mean? You understand? So yeah, that's that on function. Then let's go to events. Event is not really a type. Event is not a type, but it's a way that we use to store data in Solidity. So let me come down and do event. So let me give you kind of its little background behind events. You know, storage is costly on the blockchain. Like for a system whereby before you do any state modification or state change, you need to pay, then you would know that storage is costly. You get. So events is a way that you kind of, event is like, if you know the idea of logs, if you understand the idea of logs, then you understand what we mean by events. So events are like logs. So it helps you store data, but not inside the smart contract. You get. So it is stored on the blockchain, but it's not stored inside of the smart contract, so that you can be able to use that data in the future. You understand? So with events now, we can store little chunks of data that I want to use in the future, but not inside of the smart contract. Inside of the blockchain, well, as we're storing those little data inside the contract, or we are adding it to the blockchain, like using smart contract operations, then it will be expensive. You get. So let me just show you now. Let's create an event. Then we'll emit that event. So quickly, let's do this event. Let's say paid. This name should give you an idea of what you should expect. So paid. So imagine I create a system where payments are made and I want to emit an event when a user makes a payment. So after every successful payment, I emit this event paid. So that in the future, if I want to aggregate data, I can bring everything together and make sense of the data, probably store it in my database, and depending on what you want to do. So from the name, you should understand what logs, events are, even the goal of events. So now I can have paid, you can have saved, you can have bought, you can have different things, basically. So let's give this amount. We just need amount. and let's give it time. You know, time is a very important concept in programming. But okay, I expected this, but got this. First of all, is this even used? Let me see if this is what is meant to be used. I think this is what's meant to be used, not. Expected this, but got this. Oh, okay. Let me check out something. I think Attacker. Okay, I don't have any events in this contract. So I think it's this. Let me try this again. I think I need to use this. Let me see. Sorry. Oh, okay, it works. Cool. Interesting. So now we have an event. So basically, the idea is that I created a system that I'm collecting payments. Hopefully, I will create such a thing. Yes, so I want to be collecting payments from people, and I want to just be collecting money. You understand? So I just want to be paying money to my contract for whatever reason. So I want to see that I want to keep record properly. Now you get. I don't want to be having cases whereby I'm not able to verify that somebody paid or stuff like that. Or I want to use the data for marketing. I want to use it for insights, getting insights about my company and stuff like that. You understand? So now let's create a function called pay. So let's bring in some of the concepts we learned before. This should be payable because once the person will pay money, let's make this external because we also it's cheaper to use external if you know that a function will not even be called inside. Just to cheap that thing. It's cheaper to use external. If you know that your function will not be called, will never be called from the inside, you get just use external. Because if your function will be called from inside and you now have to use these dots, that function, then it's now expensive. But if you know that it's not, you just want to be using it internally, it's better to use, sorry, externally, it's better to use external. So payable, let's say, okay, this, let's say emit MSD of value. MSD of value and timestamp. I'll talk about that quickly. So just like sorry, let me see what's saying. The error. Expected event name, but okay, sorry. I meant to do emit paid. The event name should be here. Sorry. So emit paid. So now MSG is an object, block is another object. You understand? So block has values concerning that particular block. You understand? So there's block.timestamp, there's block.coinbase, which is the person that mined the transaction, or in the case of proof of stake right now, I think is the person that added the transaction to the blockchain. So timestamp is the time, and but this time now is not normal time; it's in numbers, which is being counted. There's a way it's being counted from the Genesis block. That's why if you notice things around the blockchain, if they are trying to set a time, they'll say that at block this. Even the merge, they were like at block this, and they now estimated based on past result that it's on this day that will be block this because they understand how many minutes or how long a particular block takes. You understand? So let's just quickly call this function and move quickly. So pay. Okay. I've not deployed this. Oh, I'll have to keep bringing in addresses now. Okay, so let's deploy this again, and let's call pay. Okay, now see this kind of this good UX that Remix does. These functions are functions that doesn't alter state. The ones that are blue, they don't alter states. add this one that show yellow, the alter state. Then this one that show red, the collect payment. Take note. So this one now called pay. If I want to pay, here's where I'll do it. Let me this on Remix. So this is now you if you are using it another tool, there are ways to do it like EtherJS and Web3.js. But if I want to send money with a function, I'll come here now. I'll come here and add it. Okay, if I don't want to add it in way, let me add it in Ether. Because now I have wow, I have a lot of money. I have 99 Ether. So I'll use 10 out of it. It's a small thing. On Remix, we have free money, so using it like that. So 10 Ether is small thing compared to 99. Yeah. So we now pay. You get we pay, we click on pay, and the function worked successfully. Now let's go and see the events. Let's see the events. Boom. So look at it here. Amount, time. See that time I was telling you about? This thing now is being counted from when the blockchain first started. This is how they calculate it. So if there's a way to convert this thing to know the particular time you are in, if you start from when the blockchain started, then this ether now that I sent, 1 ether is equals to I don't know how I'll call it, but 10 raised to about 8 way. You understand? 10 raised by 8 way. So now if I have 10 way, 10 ether, then I'll have 10 raised by 19 way. You understand? So it's no more 1 is equals to, it's now 10 to way. You understand? So this is the ether I sent and this is the time. So this is how events work. Now it's even under logs, just like I said. The title of this is logs. You get. So it's logs. So sometime in the future, I might want to use this data for something. You understand? Assuming I was storing this data on the blockchain, it will be very expensive. Because logs are is a key part of the blockchain and the smart contract generally. So that's that on events. Okay, we are moving. I talked about mapping yesterday. Control structures, which is if else. Please, you go and do that yourself because you go and check that out yourself because it's not complex. Trust me, it's not. I think I already used this somewhere here. Yes, this is it. Just how if works. If I'm going to do another block, I'll just do else and stuff like that. So do something return bagged. So this is it. Return, not returns. So this is if else statement. So then let's talk. We've talked about payable and non-payable. We've talked about function visibility, which is pure external, internal, and private. With then for loop, I would also want to check that yourself. Trust me, it's not complex. It's still the same idea you know from JavaScript. So now we'll talk about function types. Let's talk about modifiers. So now I want to create a foundation for your understanding of modifiers. So let's say that we wanted to do this now. We wanted to say this function now do stuff. So we have used do something. So let's use do stuff because names are finished in my head. So external, let's make it external and just return stuff because it's doing stuff, so it should return stuff. So returns string. Now we want to but there's an issue, or rather, I want to do something. We want to make sure that only the owner of that contract can call this function. What comes to mind? First, if statement, control structure. So let's use that. So if msg.sender is equals to owner, call this Understand? This is just what we do here. Now this works totally. It works. If this equals to this, give us this. Let's see what it's telling us. I think it's about view. Is it about view? Let's put the let's see. Remain unsigned. Oh, okay. I think it's got to be conditional. But yeah, now this works. But imagine that we have 10 functions that we want to put this thing in. Like we have 10 functions that want only a particular user to call. Now, first of all, it breaks this programming rule called dry. Don't repeat yourself. So imagine I'm pasting if one equals to this, if one equals to this, every single place in the contract. That's bad code, to be honest. So now a way to solve it is to create one that we can use everywhere. So let's give this a modifier. It's called modifier, and let's call it only owner, because this is what it's called in a lot of contracts, only owner. So what it does is it first checks require, just does require. In fact, I would have used require instead of this if, but yeah, require that msg dot sender equals to owner 3. Else, this second part is just second argument is not a must, but it's good for readability. So not owner. If it's not, that's enough owner. Not owner. Then the second line will be this underscore. What does the underscore mean? It means that if you are able to pass here, run the function that it is tied to, because on its own, modifier is nothing. Do you get? Modifier is nothing on its own. Modifier cannot run, like it's not a function. If I deploy now, I will not see modifiers here. From the name itself, modifiers, they are modifying something. They are like dependent. They are helping something, but they are dependent on another thing. You get? So that's how it works. So if you've used Python before, there's this thing called decorators. They kind of add more functionality to another function. But on its own, a decorator, in fact, from the name decorator, you have to decorating something, you have to modifying something. So on their own, they don't really do much. I don't know what is happening in the call. People in the call are just reducing. Like okay. Well, okay, so far have I been making sense? You understand what I've been saying so far?
I've been following you, Sha. But we'll have to go and redigest it.
Okay. Yeah, that's fair. I think we are trying to be fast. At the same time, it's a lot, but at the same time, I don't think it's very complex. So once you get the video, you can just go through it again, and I'll update the code, the repo, so you can just
Please update the repo.
Yeah, I'll update the repo, so all these things will be there, so you can go and look at it again. But are they complex? Because I feel like apart from this, the data types and these ones are like.
The only issue now is not your explanation, but the issue is when we are supposed to use which.
Yeah, don't worry. Very soon you have like
So that's the issue. Because if we see all of this, we don't know where we are going to put it. We don't know how we are going to arrange it in order for us to get the output that is being required.
Yeah. On your assignment, you also see it. Don't worry, I'll give an assignment today, and you see it there. Trust me, you see it. So, but yeah, I think okay. Let's just go ahead. Let's go ahead. Yeah, let's go ahead. Can we also have the class videos? It's not on my. It's not. I'm not in charge of that. Like, I don't know how quick they send the videos to you guys, but the one for yesterday is ready. I don't know how they send it to you guys, but yeah, I'm not in charge of that. Sorry, I'm not in charge of that. I'll probably ask how they do it, but I'm not in charge of sending out videos. So yeah. So now, like I said, this first one does the whole conditional thing. This function, the first part of the function takes a boolean. When I mean a boolean, true or false, you know, when you evaluate this, it gives you true or false. You understand? Once you start using comparison of operators, you now know that you're talking about boolean values, because when you finish comparing it, together give you, is it true or is it false? Is A equals to B true or false? They should send the video links to the YouTube channel Web3. Oh, I don't know about that. 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 So yeah, basically this part takes in a boolean. So when you finish when it evaluates this, it gives it true or false. So now if this is true, it comes down here, and this underscore just basically means run the function that is modifying. Else it will throw an error and it will give you this message, not owner. So now how do we use this? So now, first of all, we will remove this conditional because we have seen something that is better. Remove this conditional, and we just come here and add only owner. Simple. And now we can now take this only owner and keep adding it to all the functions that we need to do this user check or owner checking. Understand? So this owner is this owner is 3. Let's see. The owner is 3. Let me see 3. Okay. Now let me deploy this function again so you can see what I'm saying. So let me call this function. You know, this code, this address here is not the same as the owner. So we are expecting an error bar. So let's see. So let's say do stuff. Where is do stuff? So if I did do stuff now, we have an error. Let's read the error. Okay, wait, let me clear this so it doesn't. Let me call it again. Do stuff. And we have an error. Let's say this transaction has been reverted to the initial state, blah, blah, blah. So let's see the error. They're telling us this is even another error. Overflow. Where am I? Where is the overflowing? Where is this overflowing? Okay, this error is not descriptive, but I think it's still the same error. But wait, let me check. This. Okay. Yeah, it's the same thing. But it's you know what actually happened is that if you try to run a function and it fails, it will give you an error, right? But this message came up above. So see this place. Where is it again? Okay, look at it here, not owner. You get, so this is where it came and like gave us the reason provided by the contract, not owner. You get, so this is mainly what we are talking about. This is as a result of, not completely sure, but I think, yeah, it's actually the same error. I'm not explaining what I don't understand, but basically gives us this not owner, which is what we are looking for, and this is what we gave it here. Understand? So the main reason why modifiers are great is because you can use it in multiple places. You understand? So yeah, we are progressing. Or if you don't understand it, no problem. No problem. We'll get you. If you have any question, don't hesitate to send me a message. I might not reply instantly, but I will definitely reply your message, and I will try to explain at my best. You understand? So please reach out You can, in fact, if you don't send a DM, you can just send it on the group and tag me, and I will reply you there. If you, yeah, just for the sake of other people. But if you want to send my DM, no problem. I would reply that too. So let's talk about fallback functions. Fallback functions. Have you ever thought about sending Ether to a contract? Like, because a contract address and your normal Ethereum address that used to collect money, there's no difference, bro. So thinking about it, you'd see that if you're allowed to send Ether to contract addresses, without any form of restriction, then a lot of people will actually be losing their money. Sure, if I wanted to create a contract, I would make it possible for it to collect money, and I will make it possible for it to also send out money, even if that is not the goal of the contract. So that probably if you mistakenly send money to my contract, it's not that I'll not tell you that it is lost. I'll probably be able to get it for you from my contract, because a lot of all these popular contracts like Uniswap, a lot of people are mistakenly send money to them directly. And I don't think there are ways to send out money. I don't think they're putting a way to send, or they might do it because it's on a, okay, Uniswap don't use upgradable contract, but other people use upgradable contracts. So there'll be a way to send out money. But sure, if somebody mistakenly send money to your contract, you don't want the money lying around. It's either you're getting it out. If you don't give back to the person, that's your business. If you want to send back to the person, that's your business. But basically, sending out money from your contract should be a thing, because people really make those mistakes. So fallback function is basically a function that if you try to call a function that does not exist in a contract, then it falls back to this function. So this is how it is. So it takes, the name is simply fallback, and it takes in, okay, fair. Let me actually show you something now. Let me try to, is there a way to send? Okay, let me try to send money to this particular contract. Where is it? Okay, I've not deployed it without adding any fallback function. So the reason why I'm saying sending money, it's not just sending money. Even if you try to call a function that does not exist in a contract, it will go to the fallback function. Do you get? So for instance, now, I'm coming. Let me show you something. The only reason why you are seeing all these things here is because of this is Remix. If this was not Remix, you have to get an API and add it so that you'll be able to call about this. You call some functions. And now, since the API is editable, you can add any function you want. But what if that function is not existing in that contract? Then it falls back to the fallback function. And also, if you send money to the address, just like a normal address, it will also go to that fallback. And there's also another one which is called the receive function. But the only difference between receive function and fallback function is that receive is for only if it's mistakenly send Ether. Fallback is both Ether and call functions that does not exist. So let me just write it down. Fallback function calling for calling, if you call non-existent functions and you send Ether, but receive is just send Ether, then it will just, these functions, in fact, you don't even need to perform any logic inside of them. You understand? You can just leave it like that. Like, just so far you define the function, you can leave it like that, and any money that enters comes into the contract. You understand? So you see here, they are showing the balance. I don't know if you saw the first one. When I sent that 10 Ether using this pay function, it just came here and it was showing here. So the contract can store value. So I want to try to do something. I want to try to send money to this contract. Let me try it. Okay, I want to send money to this contract. Don't mind this right now. I want to send money to the contract. Let's see. Where do I send? Okay, let me send 10 ether. I want to show you something. So when I click on this, so look at the message here. This is small. Let me increase it. Let me see what they say. They said in order to receive ether transfer, the contract should have either receive or payable fallback function. That's what I was saying. So because of this does not have any of this, they're telling you that you cannot even send. Like it will not even, it's not that it will not go, it will fail. So the contract cannot even receive it at all. So now let me go back and add fallback. Then you see how it works. You see the magic. Sorry. Right out of time. We've covered a lot today. Like I said, you don't even need to put any logic here. Sorry, and also you need to add. Okay, it doesn't allow. It doesn't. You don't need to add payable. Okay, interesting. I thought you need to add payable. Or before you needed to add payable to this function, but right now you don't need to add payable. Cool. So if I deploy this now, if I deploy this, deploy. This international limited, blah 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 blah. Should be payable if you want. Let me see why it's given an error. Okay, was given an error. Interesting, it works. I think this came in as a string. Wow. So let's see now. Let's try to send it now. Let's try to send. You know, the first time it was giving us a lot of stories. So let's try to send it now. So this basically means empty string. This is the hex representation of empty string, right? Yeah, like not empty string basically. So this is meant to take in a hash value because the core data, like, so this is what they wrote here, low level interaction. So assuming I didn't want to go through all these places, and I know the like because how this works is that when I click on this, it creates the data that should be sent to the contract containing every single thing, both the function it to call, the arguments that the function that it's calling would contain, every single thing that it needs to call a function successfully, it sends it. But if I don't want to go through this stage and I'm just this geek that knows how to convert things by himself, or I went to convert it using another tool and I come here and paste it, I'll click on transact and it will do the same thing that it will do here. But the reason I'm putting OX is that if I don't put anything here, it won't run. So I'm putting OX, which means empty string, or empty string. Understand? So let me come here and write 10, sending 10 ether. You know, when you have a lot of money, just keep sending it. Yeah. So yeah, 10 ether, and I click on transact. Okay, it still gives me the same thing. Wait, let me see. Why didn't I have? Why is fallback not showing here? There's a problem. Did I deploy it? Fallback. Okay, let me add payable. Let me see. I don't know why it's not showing. It's meant to be showing outside of this place, even if it's okay. Let me deploy it again. So This you deploy. I'm having an error. Let me increase this a bit. Let me see what the error is about. Because I got the same error the first time. I don't know why. Let me try it again. I think it's because of. Let me try it again. Oh. I think I know why. This value was still here. That 10 was still here. And if you want to be able to send money, if you want to be able to send money while deploying your contract, you need to add payable here. So that's why it's giving that error. So just take notes. If you want to be able to send money when deploying, you should add payable to the constructor because the constructor is a function. The only thing is I can only call it once. So let me see if payables. Fallback is here now. Fallback is not here, but okay. Let me actually see if it will work this time. So now I want to send money to this contract. And it has a fallback. Okay, external payable. Okay, let's see if it works. So OX. Adding 10 ether. Let's see if that works. Your callback data should be a valid Hexadate, at least 1 byte. So let me try this. This is not working. Works. Callback data should be valid hexadecimal value inside at least 1 byte. Let me see if this works. Should be as amount. Okay, OX. Okay, it worked. But note, this OX23 is not enough. But assuming this was something, and after decoding, and it finds out that it is one of these functions, you can call the function. But OX23 is not. So let's see what happened here. Okay, this is the value. If you see it, this is value. Let's now see the new balance of this contract. See, it is now holding 10 ether. You understand? But before, it did not allow us send ether to this contract. But now this contract owns 10 ether. Back to the thing I was saying. This 10 ether now is lost because there's no function that tells me how to telling me how to send it out. So this function will be here throughout the life. This ether will be here throughout the lifetime of this contract. So that's lost like that too. So the same thing for receive, but just know that it's better to use fallback. Or in fact, most times when you want to use fallback, you're probably using fallback in something called a proxy function. Sorry, proxy contract. If you don't understand the meaning of proxy, basically instead of going straight to something, you would tell something to do something for you. So a proxy contract is used in upgradable contracts. I don't want to. Okay, don't worry. Don't forget about it, but don't bother about it that much. But yeah, in a situation whereby you want to use one contract to call another contract, you need a fallback because almost all, if not all, almost all the function calls that will be coming into that contract will be going to the contract that it's supposed to be calling for you. Do you get? So it's just like it will be an intermediary. So in a normal proxy function, in normal proxy contract to have like only like let's say 2 or 3 functions, then you do not have a callback function. So once we are calling those functions that it does not exist, it will call the fallback function. And the fallback function will not tell you what to do. It will not tell you that it will not tell you the contract that you should send that request to. You understand? So the same thing here with receive, but let me not do receive. Just know that the receive works exactly the same way, just that receive only optimized for sending ether if you send ether, but fallback optimized for if you both send ether and if you call a function that does not exist. Yeah, I think we are done with week 3, right? Yeah, I think we're done with week 3. Let me see. It's almost time, almost up, but let me see what we have for. Let me go to week 4. Okay, week 4. Okay, let me see. How does this work? Like I will create another contract and use text to explain these things. Then I would add it to the repo because our time is up. What do you guys think?
Okay, that's fine.
All right, all right. Who
That's
else? Yeah, it's okay, right?
Yeah.
yeah. So
All right, all right, all right, all right, all right. Cool. So because I'll give an assignment. I want to send the assignment before the end of today, but you submit it like before the next class. So I'll try to do I'll try to see if I can do that, the one for before later tonight, or if I don't do it later tonight, it will be tomorrow. But you would submit the assignments before the next class, which is on Tuesday next week. On Tuesday next week. Yeah, on Tuesday next week. So yeah, so far I know it's been a lot. Like we've talked about a lot of things. And let me know if does anyone have a question? Ask your question. Like ask your questions. If you don't want to speak, and just type. Or if there's any, I've been talking since, anything you want me to go back, so I'll just go back to it. Okay, something I didn't touch for this week 3 is error and data location. So I want to talk about data location now. And for the error, user-defined error, it will be part of your assignment. So there are 3 locations. So I just from a high level, there are 3 locations, 3 memory locations in Solidity. So there's storage, there's memory, and there's core data. Now, storage is the general state of the contract. So all these things defined outside. This is stored in the storage. This is stored in the storage. The contracts are in the storage. This varies about the storage. Everything is outside of a function. Everything. That's that for storage. Then you now have the one in the memory. So thinking of memory, think about RAM. So the way RAM works is that it stores data that is being processed. And when it finishes the processing, it throws the data away. Rather, like it just uses it. So imagine that you want to do 1 plus 1. And when you're doing 1 plus 1, the 1 plus 1 is in the RAM, is doing everything. When it gives you 2 and it returns to the user, the 1 plus 1 is lost. You're not using it again because it has finished the operation. So the memory is inside of a function. You understand? Most times the memory, it's not like most times in Solidity, you can't declare memory, you can't use memory outside of a function. You understand? You either use it when you're defining it, when you're passing in the argument, when you're defining the return statement, or when you are just creating a function. So when you're creating a variable inside the function. Let me show you the one I used yesterday. This. I use memory here, but I can't take memory and use it outside here. It won't work. You get. So think about memory as RAM. It stores data that is being processed inside a function. You understand? Now, the difference between core data and memory is that the core data stores data about the function. So, for instance, now, let me try to change this to core data. Let me just show you something. Let me try to change this up to core data. Let me see if it works. It doesn't work. I think I tried yesterday. It doesn't work. right? So it's saying blah 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 blah. It's not okay. It doesn't work, right? So call data stores data about the function. So if you're passing in data here and you change this to call data, it will work. This should work, right? This should work. This works. This is cheaper, first of all. And this is non-modifiable. Meaning, if you set something as memory now, you can manipulate it inside of the function. But if you set it as call data, it contains data about the function. So you can't even modify it. So it's actually cheaper. So here now, if I use call data here, it's even better. You get it's better. But I can't use call data when I'm setting, because this is something that might change, and this is something in the in this, like, it's running here, so it's probably going to change. I can use storage. Okay, no, I can't use storage because even the test data itself, it is a struct, so you can't use storage. I think I tried yesterday and it didn't work. So yeah, that is that on storage, memory, and call data. On your assignment, I would want you to look at errors, because yeah, just look at it yourself. They're not hard. Trust me, they're not hard. It's just, in fact, it's actually new to Solidity. It's like it's not a it's a bit recent. I think 0.8. I'm not sure, or 0.7. So it's not complex. Trust me, it's not complex. But I would it to be, you know, you can go and look at it. You can start looking at it, errors, like define errors, because like it's not like I've not talked about errors already. Like this thing now throw an error now. This thing throw an error. Understand? But this one is an error that you define, just like you're building a system and you're expecting a particular set of errors, and when you see them, you want to do something, or you want to throw errors. So when the user sees it, it knows what you understand. So basically, that is how it should work. You get? So yeah, that's it basically. So once again, please ask your questions, please. Or I would ask you to somebody to explain to me like what they understand so far. Which yeah, that actually works too. Okay. Okay, that's fine.
We have to digest everything first before we can know what to ask. Because a lot is taking right now.
Yeah.
Yeah, it's
Yeah.
actually overwhelming right now because you've said a lot of things today.
Sure.
In fact, I got lost lots of times before I found myself again.
Okay. Yeah, it's just like we are trying to be fast and there are stuff like that. But to be honest, when you're reading, don't hesitate to ask questions. Even if you don't want to ask me, you can just search, but just be curious. Ask questions, like search. You understand? A lot of all these things, just a 5 minutes article will just clear you. Or you can just chat me up, like I said, and we'll sort it out. I'm just trying to be fast. You understand? I'm trying to be fast, and my prep was not that fast, but yeah, it's a lot to take in like less than an hour for the
Yeah,
second part.
I was actually following, but then I ran out of data, and by the time I recharged and came back, I got completely lost. So I'll just wait for the video and go over everything again.
Okay. That's fine. That's fine. That's fine. All right. So okay. So everybody's saying they are okay. It's fine. It's fine. So thank you very much for coming to today's class, and hopefully when you check it out yourself, it will make a lot of sense. Hopefully. I hope it will. Yeah, but I want it to. Because I know
Okay,
that
please.
okay, go ahead.
Okay, I wanted to ask about the repo. You say we're going to push to
and then drop the repo for us.
Yeah,
Have you done that? Oh,
yeah, I already dropped the repo on Slack.
okay, okay, okay.
I already
Thank you.
dropped the repo on Slack, so I'll update it right now with this with this one I just did now, and I also updated with the one I talked about chapter week 4. I'll just try to do a more comprehensive. It will be more comprehensive than this one because I'm talking while I'm writing. But yeah, I would make it comprehensive for you
Okay,
guys.
thank you.
Yeah. So all right, I think that's all for today. That's all for today.
Okay, thank you.
Yeah, you're welcome. Have a good night and calm down and look at it. It will sink. It will sink in, like somebody said. Yeah. All right. Take care. Bye.
Thank you.
Bye.
Yeah, you're welcome. Yeah.